So this is my short ISP, the EEG recording device. It was supposed to be a headset, but it's not really anymore. Um, I'm really happy now because I got this working in my presentation. Before it was not working, um, but now it is, and I'm very happy about that. In the presentation, I had some Bluetooth connection issues, and it was a busy week. So here, I've got it working, and to show that I've got it working, I'm going to close my eyes, and it should detect the brain waves that respond to closing your eyes, and that will appear on this white thing um, as a spike. I'll explain what this white thing is, but when I close my eyes, there's going to be a spike, noticeable spike, while all the others are kind of low. So here goes. I'm going to close my eyes now. You can sort of see a spike there. I'm going to switch to a different window because this this white thing, which is an FFT, I'll explain what that is later. It basically just transcribes position time sine waves into its frequency components. And what it has is it has different windows, which are different ways of showing. So this is a hand window. I'm going to close my eyes again, and we'll see what happens. There should be a spike around this area. You can sort of see it there. Oh, now it's flatlined. That's the thing with this. Sometimes this will flatline. Not too sure why, but I've been trying to deal with this issue for a while. But anyway, now I'll come back to you when I fix this, but uh, yeah, it's just doing that right now. Not too sure why. Okay, here I'm back again. Uh, it's now I've kind of fixed it a little bit. Um, I'm not sure why though it's happening. I'll have to find that out later. But the other thing I want to show you was the well, first off, the other window of the FFT, and this is a flat top window, and it just basically makes all the tops flatter. So I'm just gonna close my eyes again, and I'm gonna do that now, and there should be a spike, yeah, as you saw in the other videos. Here. Yeah, there you go. I just saw one. And now it's flatlined again. Okay, so I'm back again, as you can see, now recording. Um, and yeah, I think that issue had to do with the connections between um, my skull and the electrode and the board as well. And now it's all good again. Um, but anyway, the last thing I want to show you in regards to EEG or not EEG, sorry, EMG are blinks and other facial movements that you can detect. This is called EMG, and it's different from EEG because EEG is brain waves and EMG is facial movements. So as you can kind of see here, there's some spikes that are going on, and that is due to me blinking. So up here I've got a blink counter, and if I blink really hard, the blink counter is going to increase, and this bicolor LED is going to change color. So let's see if I can do that. Yep, there you go. See, it's now green. Do it again. Oh, yep, 4. Yeah. It's a little bit kind of like cheaty way of detecting blinks because I'm looking for a certain value of how high this graph goes instead of actually looking at the whole pattern to see if it's blinking. Let's see if we can do that again. I guess it doesn't want to. But you can see in also the other videos, this thing was turning on and off um, before as I was blinking, and now it's kind of flatlined again, probably because of the connection. Yeah, there we go. Oh, yeah, now it's doing that. And this is the other problem with these electrodes. You get some bad connections, and you get extra noise. Okay, here it's back to normal again. That's what I believe was going on there. And as you can see, yeah, the blink counter increased because I've got it set to a value to trigger the blink count when the graph reaches a certain value. So let's try blinking again. Yep, there you go. Again, again, again. Pretty fun. The other thing I want to show you was the other movements you can detect. So I'll direct you to the top part of this graph, and I'm going to move my eyes left and right. So as you can see, there's these dips and valleys that correspond to that, and that's me moving my eyes from to the right. I'm going to move them to the left, and it's going to be in the opposite direction. As you can see, yeah, there. And if I move right, opposite direction again. This also can detect some, if I raise my forehead, my eyebrows, there's just a lot of spikes there. Can also do that. And that right there is all EMG. What I've got open now is another processing sketch that is meant to record EMG data such as blinking, moving my eyes left and right, and it records that because I wanted to put it in a machine learning algorithm so that a network can learn to classify this data as it's being recorded real time. Now, I did not get to doing this because of time constraints, but I have got the recording process down in this sketch. So what I'm going to do is I click space. There's going to be a green bar that shows up, and after the green bar passes, I'll do the action, which will be a blink, and then once the red bar passes, it'll stop. So here you go. Here we go. The green bar's there, so I blink, and then the red bar. So now it's in the classification stage. These are the purple bars where it's classifying the data. So here nothing really happened. So I'm going to click enter to save that data to a file. The purple bars move, and I can move again the purple bars with arrow keys. Here nothing is happening, so everything between the purple bars, nothing happened. But here, this is where the blink happens. So I'm going to switch my label to a blink, in this case a right blink, and classify all this as a right blink, all the stuff between the purple lines. Now once it passes, I'll classify it again as nothing, and then resume the recording by pressing space. And if I open this file here, it saved all that classified data to the file, and if I open it, there we've got all the EMG data that was just recorded and classified. Now I'm going to give a really basic rundown of how it all works. There are EEG waves that correspond with certain brain patterns. In the case of closing my eyes, alpha waves are detected, which occur at a frequency of 8 to 14 Hz. That's why there was a spike around the left side, since the FFT histogram presents the frequencies that make up the signals from lowest to highest frequency. To detect these waves, these electrodes were placed on the O2 and FP1 areas, and the FP2 area also had an electrode placed to detect EMG, which were those facial movement patterns. Since the O2 area contained hair blocking the skin as opposed to the other areas, the signal kept flatlining and produced more noise, so to help with that, a headband was used to create pressure for the electrodes to create good contact with the scalp. There is also a ground electrode connected at A1 behind my ear to reduce electrical interference from the body. The signals go from these electrodes to the PCB where it is filtered, amplified, and fed into the ESP32, all powered through a 9-volt battery. A bit of important background on the PCB, this was my first time designing and soldering a surface mount board where I mixed hand soldering and SMT baking together, and admittedly, the solder joints are not too clean, but it did the job.
The Arduino code on the ESP32 reads the signals and outputs them serially to the graphing sketch that I wrote on processing. Originally, I had tried Bluetooth, but it failed due to the large amount of current it takes. Here, the sketch has a custom FFT algorithm I wrote, which required a lot of research and writing of some other test sketches for me to really understand how the FFT works. The code right now is not that efficient as I sacrifice that for understandability. Also, here's the other sketch I showed that records EMG signals for input to a neural network. Here's the part to detect blinks. It sends a message serially which is picked up by the ESP32 where the bicolor LED changes. As future improvements, I will make the code more efficient and will implement the machine learning algorithm to better classify the EMG signals. I really do want to talk more about this project as there is a lot more to cover, but the video is long enough already, so I'll leave the details in my DER. But before the video ends, I want to showcase some aspects of my long trek, starting with my first prototype and my initial setup using an oscilloscope. I then started learning about the complex nature of FFTs and DFTs, followed by writing the first software sketches. It was then a rush to get the PCB designed and soldered, and to get everything working while dealing with chump and other coursework. And of course, I ambitiously tried to use machine learning. In the end of the final week of the submission, not much worked during my presentation, teaching me how to embrace failure and to not be so ambitious in the future, though afterwards I took my teacher's words to heart and set out to cross the finish line to the best of my ability. And by some miracle, I did, and to that I am grateful. I'm really happy with what I've learned, what I've achieved, and the countless hardships I've went through. It has seriously been a life-changing experience, and I hope I can take the lessons I learned to heart. If you're still here, I'm impressed. And I do want to say thank you for listening and watching, because it has been one heck of a long journey, with still lots more to come.